And I'd like to welcome you to this video here. We're trying something out a little bit different. So what we're going to do is we're going to take a look at a little bit of differentiation between the two. Just cover this real quick, and then we're going to go into a lab, and we're going to try and keep this under 10 minutes. So first of all, crypto maps require an ACL to define what traffic comes up. VTIs do not. You actually create a virtual tunnel interface, and the encapsulation type on the tunnel interface, or the tunnel mode, is IPsec for IPv4. So it's actually a little bit easier there because everything that gets routed through that interface is encrypted rather than only what matches an ACL. Now, that doesn't mean that we can't filter traffic, but it just means that it's a little bit easier to define what goes into the tunnel. Simply whatever gets routed across it with a VTI is encrypted. Crypto maps make it a little more difficult to run routing protocols over the VPN, and the VTI interface there can participate in the routing protocol process. So we can actually, whatever address is on that VTI, we just add it to our routing protocol. We'll do that with EIGRP in the lab, and you'll see how easy that is. Crypto maps are old and nobody likes them anymore. While that might not be true, some people may like them still, and they still are used, but they are sort of an older technology. VTIs are the hot and sexy configuration for VPNs nowadays. And so we want to definitely be familiar with both, especially if you're a CCIE candidate. You want to be familiar with both, but the direction is sort of towards the VTI configurations. Crypto maps are not as easy to configure. Maybe. VTIs are super easy to configure. I think we'll see that as we go through the configuration. So let's go ahead and take a look at our topology here. And basically what we've got is this NBMA kind of cloud sitting here. And we've got interface F00, which is 172.17.02. F00 here, 172.17.03. We're going to use some loopbacks. Loopback 0, I think, here, and loopback 0 here. And what we're going to do is use those to simulate a network that's sitting behind router 2 and router 3 that we want to route traffic across through a tunnel. So we are not going to configure any routing for this interface F00, which we're going to consider to be our connection to the internet. We'll assume that we have connectivity. We'll actually test that. And then we'll do a 192.168.2.2 network over here, and a 192.168.2, or actually .3.3 network over here. And then we'll add that to the routing process along with our tunnel 0 interface, which is going to be our VTI interface. So that's one way to do it. That's the VTI method. The other method is to simply put a crypto map on these interfaces and define that we want 192.168.2 traffic to 192.168.3 traffic and vice versa to be encrypted. So we can work through each of these configurations, and let's go ahead and take a look at a demonstration. Okay, so I'm on router 2 here, and on router 2 the first thing that I'm going to do is show IP interface brief, just because I want you to see that I've got the loopback address created already and the fast Ethernet interface is there. And let's ping 172.17.0.3 just to make sure we have connectivity over there to router 3. And we do. So the first thing we'll do is the crypto map configuration. So crypto, let's actually go here and let's just create an ISACANT policy that can be used by either one. So crypto ISA policy 10, encryption, triple DES, hash, MD5, authentication, pre-shared keys, and we'll do Diffie-Hellman group 2. And let's take a look at that crypto configuration here. And the reason I'm doing this is because I'm a little lazy, or I just want some speed, and I want to make sure they match on both sides. So I'll drop that into router 3 there. Back here on router 2, I'm going to go ahead and define my pre-shared key. So crypto ISA key, and then since I'm going to peer to the 172, I'll do Cisco 123, and then I'm going to peer to the address, Cisco ISACANT key 0, Cisco 123, address 172.17.0.3. And then I can take this I know I need to modify it a little bit, but I'm going to copy that over here and change that to 2. And now I know that they both have the same pre-shared key. The next thing that I'm going to need to do is create an access list. So we'll come back here to router 2. We'll go access list 101 permit IP from 192.168.2.0 000.255 to 192.168.3.0. And now we've got our crypto ACL. And again, this crypto ACL we'll paste here and modify. Be careful with your cut and paste. Make sure that you modify it everywhere you need to, or you can certainly get yourself into trouble. Now on R2, we're going to go ahead and create a crypto IPsec transform set, and we're just going to call this AES1, and we're going to do ESP AES. We'll do 192, and I don't care about a hash, so we'll just leave it at that. So let's go ahead and do that. We'll copy that, drop it in over here. And now we've got our transform set, which is in tunnel mode by default. Okay, so now let's do our crypto map, and we'll give it a map tag of, let's say, GC. Okay, so crypto map GC, and we'll give it a sequence number, and we're going to tell it to do IPsec ISACAMP and use ISACAMP. And now look at it, tells us that we need a valid access list to be configured. So I'm going to say that I want to set the, or actually let's just do match address 101 because that's the access list, set transform set, and I think we called that AES1, and then set peer 172.17.0.2.3, and that should do it for our crypto map. And then I'm going to go into interface int F00, and I'm going to apply the crypto map, and we'll say crypto map AES1, or actually we called it GC. There we go. Alright, so now ISACAMP is on there. Let's do the same thing over here. So crypto map GC1 IPsec ISACAMP match address 101, set transform set AES1, set peer 192.168 dot, actually 172.17.0.2 in this case, since it's the other side, and then interface F00 crypto map GC. And that should enable things for us. Now let's just quickly do a show IP route. And you notice that we have 192.168.3.0 and 172.17.0.0. We don't have a route actually to 192.168.2.0. So what needs to happen is if the router is going to route packets out of the F00 interface to get to the 2.0, which would then pick up the crypto map, I need a route. So I'm going to go IP route, and I'm going to say 192.168.2.0, and I'm going to send it to 172.17.0.2. And then I'll just copy this and make a mirror image of it on the other side. And this is going to go to 3 if we try to talk to 3. All right, so that's our configuration. And let's go ahead and ping 172 or 192.168.3.3 and source that from loopback 0, and let's see what happens. And we've got success. We'll show crypto ISA SA, and I can see I've got an ISA Camp Security Association that's QM idle. I'll do a show crypto IPsec SA, and I actually have a SA with packets encrypted and decrypted. So my tunnel is up and my packets are secure and being encrypted.